So today what we're going to do is we're going to talk about continuous functions. And so you just got done doing an activity that actually illustrates continuity. And so if you look at the definition of continuous function, it is a graph which has no breaks, holes, or gaps. No breaks, holes, or gaps. And so that's the definition of a continuous function. The other definition you need to get down that we will talk about is what is known as a limit. A limit is kind of the fundamental, it's kind of the fundamental idea of calculus. And so limits are studied a lot in calculus. We're not going to study them to that extent. We're going to give you an introduction over those so you understand them a little bit. Is that what you're saying? But yeah, so the limit is a concept of approaching a value without necessarily ever reaching it. So the concept of approaching a value without necessarily ever reaching it. So this is, below here is the symbol for a limit. And below that is how that is read. So how we read that symbol is it says the limit of f of x as x approaches c is L. So we start here with the limit of f of x as x approaches c is L. So that's the order it goes through. Okay, let's show you that again for those of you who are kind of wondering how that went. Okay, so here we go. The limit of f of x, that's how we read it. The limit of f of x as x approaches c is L. That's how the order goes. Now f of x is any function. It could be x squared plus 4. It could be x. It could be x minus 5. So f of x is any function. X approaches c. X will stay put because that's our variable. C will be a number. Might be 5, might be 10, might be infinity. Okay, and so that's what we're going to talk a little bit about. Now, this next slide is going to be dealing with the activity that we just got done doing. Okay, this next slide talks about discontinuous functions. Okay, discontinuous functions are functions that have holes, breaks, or gaps. Holes, breaks, or gaps. That's a discontinuous function. Basically, it has what's known as a discontinuity. Which, if we think of the word continuity, that means consistent, that means it follows through. And so, the biggest thing I want you to understand here, I don't want you to name infinite, jump, and removable. You don't have to do any of this. Okay, what I want you to know is the following. I want you to know that this is a discontinuity, so you can draw a picture of it in your notes. I want you to know this is a discontinuity, and I want you to know that this is a discontinuity. So what would be a good thing to do is put discontinuities, and then list those three. Okay, just draw a picture, draw an example of those three. Your book identifies those. That's really not necessary, I guess, in my mind. And so we're going to talk now about the activity that you just got done doing. So I gave you three different graphs. And you had to walk along them. The reason I had you walk along them is because I think that illustrates these a little bit better. So, the graph number 1. In the distance learning, by the distance learning room. Were you able to walk along the graph the entire way without jumping? Yeah. So let's classify that. What would that be an example of? A continuous function. Keeps going forever and ever. You don't have to worry about ever jumping there. So that is what a continuous function looks like. So if you were to imagine yourself, if you were to classify a function as continuous or not, continuous means you can walk along the graph the entire way without ever having to jump. Next one, number 2, that was the one outside of Mr. Waltman's office. Were you able to walk along the graph the entire way without jumping? No, you actually had to jump. So if you had to jump, was there a way that you could place one sheet of paper so that you would not have to jump? No. Okay, so of those three, I want you to look. Of these three, which would that be similar to? 1, 2, or 3?
1.
The middle one. Okay? Or it could have also been 1. I suppose you could think of it that way. Okay, number 3, that was found in the hallway outside my room. Were you able to walk along the entire graph without jumping? No. How many times did you have to jump? Twice. If you had to jump, was there a way you could place a sheet of paper so that you would not have to jump? Yeah.
Because
You could have put a sheet of paper, one sheet of paper, you could have put on that first one, you could have put one sheet of paper on the second one.
Oh, you only said
So
one.
this is an example, well, I meant one on each of the areas, okay? That one illustrates this. Now, we need to identify those. There are discontinuities, there are 2 types. There's what's known as removable, and there is known as non-removable. So we have removable and non-removable. So now what you need to do is you need to think back to when you had to jump. If you could put one sheet of paper, you removed the discontinuity. Okay, so if I'm right here, I put one sheet of paper down, I've removed that discontinuity and I can walk good. If I think back to this one outside of Mr. Waltman's office, could I put one sheet of paper? No, that is what's called non-removable. You can't remove the discontinuity. So removable means you could put, in this case, 1 dot, and you've removed the discontinuity. Here, you can't do that. That is non-removable. Likewise is that one. So what I want you to take from today, removable, non-removable discontinuities, I want you to know the difference between the 2. What we're going to be looking at Monday is we're going to be determining whether graphs are continuous. Okay, and so that's what we're leading to. Don't forget your graphing calculators. All right, and that's what we're going to be doing Monday. Okay? Okay.